Here we have AP calculus AB problem. Okay, let's go the information. Here we have a graph. In the graph of the function f of x shown above, identify the x value where f prime of x equals to 0 and f double prime of x greater than 0. So in the given graph, I have to identify the value of x for which f prime of x is equals to 0 and f double prime of x is greater than 0. So we have to consider these two stuff as conditions and find the value of x. So the value that we are going to get for x must satisfy both these conditions. That is, f prime of x has to be 0 and f double prime of x must be greater than 0. Usually, the first derivative of a function equals to 0. So where the graph of the function f of x will have relative extrema. That is, the graph of the given function will have local minimum and local maximum at where that the first derivative equals to 0. So now identify the local minimum and local minimum in the graph of the given function f of x. So we have local minimum for the graph of the given function at x equals to 1 over here, and also we have local maximum at x equals to 3 over here. Since we have local minimum and local maximum at x equals to 1 and x equals to 3, so at these two values of x, the first derivative of the given function f of x must be 0. When f prime of x equals to 0, we get two values of x. One is x equals to 1 and the other one is x equals to 3. Okay, now let's find the values of x for which the second derivative, that is f double prime of x, is greater than 0. Usually the second derivative of the function will give information about the concavity of the graph of the function f of x. So that is, if the second derivative of a function is greater than 0, then the graph of the function will be concave up. If it is less than 0, then it will be concave down. So here in this case, the second derivative is greater than 0, that is positive. Then we have to identify the part of the graph where it is concave up. So from negative to 0, if I consider this particular part, so the graph of the given function is concave up. But we have to find the value of x which satisfies both the conditions we have over here. So the values already we got for the first condition, that is x equals 1 and x equals to 3, do not come in this part. So we can ignore this part of the graph and let's consider the other parts of the graph where it is concave up. So clearly from 0 to 2, the graph of the given function is concave up. So f double prime of x is greater than 0 in the interval 0, 2, because in this interval only the graph of the given function is concave up. Okay, now so we have to consider these two values of x. So which value do we have in this interval 0, 2? So only this value, that is x equals to 1 comes in this interval, that is between 0, 2. So the value of x which satisfies both the conditions, f prime of x equals to 0 and f double prime of x is greater than 0, is x equals to 1. So the value of x equals to 1 at where f prime of x is 0 and f double prime of x is greater than 0.